This is area video number 3, and in this video I am going to show you how to calculate the area bounded by two curves in which you have multiple regions of area formed. Okay, so here's our problem. We're supposed to find the area bounded by y sub 1, which is equal to 2x cubed minus x squared minus 14x, and y sub 2, which is equal to 4x minus x squared. Okay, I have a picture of the graph already shown for you. And I'm going to go ahead and label these curves. This one here is y1, and this one is y sub 2. Okay, so in our previous examples, we were able to take these regions and we were able to divide it up into rectangles. And we just had to sum up all the rectangles, which meant we took an integral, and once we did our integrating and evaluating, we had the area bounded between the two graphs. Okay, so if I look at a section of my area, so let's say I draw in a representative rectangle here. When I look at the base of this rectangle, I get a dx, and then I want to figure out what the height is. So for this one, when I do the height, if I look at my top curve, I see that that is my curve for y sub 1. When I go and I do my bottom curve, I see that that is y sub 2. Okay, so for my height, for that section, I have y sub 1 minus y sub 2. And that gives me my height. Okay, so now if I come over to another section of my graph and I look at this region, and I draw in my representative rectangle, again, the length of my base is going to be dx. And when I go and I look at the height, this time for my height, my top curve, this time my top curve is y sub 2. And when I go to do my bottom curve, now my bottom curve is y sub 1. So we can see that the y top and the y bottom switch places for the two sections of area. Okay, so because of this, we're going to split this up into two separate areas, which means we will do two integrals to represent the entire area. Okay, so that means for our total area, we're going to take area 1 plus area 2. And I'm going to go ahead and label this is my area 1 and this is my area 2. Okay, so now if we want to set up the integrals that represent area 1 and area 2, the next thing we're going to need is the intersection points. Okay, so I need to know, where do these two functions intersect? Okay, so I'm going to do this off to the side here. Okay, so just like we did before, we want to go ahead and just set the two functions equal to each other. Set the two functions equal to each other so we can go ahead and find out for what values of x do they cross each other. So we have 2x cubed minus x squared minus 14x, and we're setting that equal to 4x minus x squared. Okay, so I see I've got an x cubed and an x squared. I'm going to go ahead and get everything over on one side. So we get 2x cubed, a minus 18x equal to 0. And now we can go ahead and factor. So 2x left over, we have x squared minus 9. So we have intersection points when x is equal to 0 and plus or minus 3. Okay, and we only need to know what the x values are because those will be our limits of integration. Okay, so back here on my graph, I have x values at -3, we've got 0, and then at +3. Okay, so now I think we have everything where we can go ahead and set up the area function. So for area total, area 1, we're looking at this piece here. So here's our representative rectangle again. Area 1, we are taking an integral from x's going from -3 to 0. And then our y top minus y bottom, we have right here, that was y1 minus y2. So y top was the, oops, y top was the 2x cubed minus x squared minus 14x. And the y bottom then was 4x minus x squared. Okay, so there's our integral for area 1. And then we're going to add to that area 2, which had x values going from 0 to +3. And y over here in our picture, if we look at our representative rectangle, our y top, the green, that was y2 this time. So that was 4x minus x squared minus y bottom, the pink, which came from y1, that was 2x cubed minus x squared minus 14x. Okay, so hard part's done. We've got the setup done. Now we just need to do some simplifying and integrating. Okay, so if we go ahead and simplify for our first one, we're going to have an integral from -3 up to 0. After simplifying, we have 2x cubed minus 18x times dx. And then for area 2, we're integrating from 0 to 3. And after simplifying, we have a -2x cubed plus an 18x. Okay, now we'll go ahead and do our integrating. So for our first integral, we get an x to the 4th divided by 2. And then we have a minus 9x squared. And that one we will be integrating or evaluating from -3 to 0. Okay, for my second integral, we have a negative x to the 4th over 2 plus a 9x squared. And this one we evaluate from 0 up to 3. Okay, so now plugging in. For this first one, we plug in 0 and we get 0. Then we're going to subtract off, plugging in a -3, we get a 81 over 2 minus an 81. And then for our second evaluation, we get, plugging in 3, we're going to get a -81 over 2 plus 81. Plugging in 0 gives us a -0, which would give us a total of 81 squared units. Okay, so that is it for area. We'll be practicing this all in class, and then next topic we'll be looking at how to calculate volumes of three-dimensional solids. So we'll see you then.